Non-uniform motion. If an object covers equal distances, even if an object covers equal distances in equal intervals of time, however small the interval may be, then the motion of the object is said to be uniform. If an object covers equal distances in equal intervals of time, however small the intervals may be, then the motion of the object is said to be uniform. Consider an object is moving along a straight path. An object is moving along a straight path. So, if the object covers 60 kilometer, if an object covers 60 kilometer in 1 hour, if an object covers 60 kilometer 1 hour and another 60 kilometer in 2 hours, and again 60 kilometer in 3 hours and so on. Here the car is covering equal distances 60 kilometer in every 1 hour. It means it is covering equal distances in equal intervals of time. If the car is covering 60 kilometer in 1 hour, if the car is covering 60 kilometer in 1 hour means the car is covering 30 kilometer in 30 minutes. So the car is covering 10 kilometer in 10 minutes and the car is covering 1 kilometer in 1 minute. Say, if the car covers 60 kilometer in every 1 hour, it means the car is covering 30 kilometer in every 30 minutes. And the car is covering 10 kilometer in every 10 minutes. And the car is covering 1 kilometer in every 1 minute. It means whether the time interval is 1 hour or 1 minute, but the car is covering equal distances. So this is the meaning of however small interval may be. However small interval may be. So whether the time interval is bigger or smaller, but the object is covering equal distances in equal intervals of time. So this is the example of the uniform motion. The next, non-uniform motion. Non-uniform motion. If an object covers unequal distances in equal intervals of time, however small the interval may be, then the motion of the object is said to be non-uniform. If an object covers unequal distances in equal intervals of time, however small the interval may be, then the object is said to be in non-uniform motion. Suppose, consider an object is moving along the straight path. So, if an object covers 40 kilometer in 1 hour and 30 kilometer in 2 hours and 50 kilometer in 3 hours, so and so on. Here saying the object is covering unequal distances, 40, 30, 50, they are unequal distances in equal intervals of time. So the object is said to be in non-uniform motion. So uniform motion means if the object covers equal distances in equal intervals of time, however small the interval may be, then the motion of the object is said to be uniform. If an object covers unequal distances in equal intervals of time, however small the interval may be, then the motion of the object is said to be non-uniform. different objects, different objects take different amounts of time, to reach a particular distance. Different objects take different amounts of time to cover a particular distance. So, some objects may move faster, some may move slower. Consider a bus is moving. From Mysore to Bangalore, covering a distance of about 136 kilometer. So, driver A takes for about 4 hours, to reach the Bangalore. Another driver B takes 3 hours to reach the Bangalore, and some another driver C takes 5 hours to reach the Bangalore. So, the driver A covers 136 kilometer in 4 hours. The driver A covers 136 kilometer in 4 hours. It means he covers 34 kilometer in 1 hour. And the driver B covers 136 kilometer in 3 hours. 136 kilometer in 3 hours. So, he covers 45.3 kilometer in 1 hour. And the driver C covers 136 kilometer in 5 hours. So, he covers 27.2 kilometer in 1 hour. So, the driver A covers 34 kilometer in 1 hour, and the driver B covers 45.3 kilometer in 1 hour, and the driver C covers 27.2 kilometer in 1 hour. See the rate of motion of the driver A, B and C. So, the rate of motion of the driver B is more. The rate of motion of driver B is more. So, the driver B's driving is faster. And see the rate of motion of the driver C. So, the rate of motion of the driver C is less. So, the driver C's driving is slower. Let us consider one more example. The bowling speed of a bowler. The bowling speed of a bowler in a cricket match is 145 kilometer per hour. It means the ball moves 145 kilometer in 1 hour. And consider one more example. You might have seen the signboard. Erected on the roadside. So, the speed limit of the sign on the signboard, it reads as speed limit of car is 50 kilometer per hour. The signboard reads as the speed limit of car 50 kilometer per hour. It means the car should not cover more than 50 kilometer. It can cover 50 kilometer or less than 50 kilometer in 1 hour. So, from these examples, we can understand that the measurement of rate of motion is very important. So, the rate of motion of an object can be measured by finding the distance traveled by the object in unit time. So, the quantity which measures the rate of motion of an object is called speed. The quantity which measures the rate of motion of an object is called speed. So, we can define the speed. speed as the distance traveled by the object, distance traveled by the object in unit time, So we can express the speed as speed is equal to distance traveled by time taken, So speed can be expressed as speed is equal to distance traveled by time taken. The speed is denoted by the symbol V and the distance traveled is denoted by the symbol S and the time taken as T. So we can express the speed as V is equal to S by T. And the SI unit of speed, You know the SI unit of the distance, that is meter, and the SI unit of time is second. So the SI unit of speed is meter per second. Next, types of speed. Uniform speed. When an object covers equal distances in equal intervals of time, then the speed of an object is said to be uniform. If an object covers equal distances in equal intervals of time, then the speed of the object is said to be uniform. Example, the motion of the hands of the clock. So in the clock, the hands are covering equal distances. So the hands are covering equal distances in equal intervals of time. So the motion of the hands in the clock is an example of uniform speed. And next, non-uniform speed. Non-uniform speed. If an object covers unequal distances in equal intervals of time, then the speed of the object is said to be non-uniform or variable. So, if an object covers unequal distances in equal intervals of time, then the speed of the object is said to be non-uniform or variable. So, we can give the example of a car moving in the busy road. When the car is moving in the busy road, it is covering unequal distances in equal intervals of time. So, the car moving in the busy road is an example for the non-uniform speed. Next, average speed. Say, the speed of an object may not be constant throughout its journey. So, sometimes it may increase or sometimes it may decrease. So, the rate of motion of such an object. Is described in terms of its average speed. So, we can define the average speed as, the ratio of the total distance, covered by the object to the total time taken. So, average speed can be defined as the ratio of the total distance covered by the object to the total time taken. Average speed is denoted by V, AV, and the total distance as S1 plus S2 plus S3, and the total time as T1 plus T2 plus T3. So, the average speed is equal to the total distance by total time taken. Now, You know what is speed? The speed means the distance covered by the object in unit time is called as the speed. The speed is expressed as v is equal to s by t, and the SI unit of speed is meter per second. Then uniform speed. If an object covers equal distances in equal intervals of time, then the speed of the object is said to be uniform. Example, the motion of the hands of a clock. And if an object covers unequal distances in equal intervals of time, then the speed of the object is said to be non-uniform or variable. The example, a car moving in the busy road. Next, average speed. Average speed means the ratio of the total distance covered by the object to the total time taken. The speed of an object gives only the idea about the rate of motion of the object. But from the speed, we can't judge the actual position of the object. So, the speed is more comprehensive only if the direction of motion is specified along with the speed. So the quantity which specifies the rate of motion of the body, and also the direction of motion is called velocity. The quantity which specifies the rate of motion of the object and also the direction of motion of the object is called velocity. So we can define the velocity. As the speed of an object in a particular direction. Or the displacement of an object in a unit time, or the distance covered by an object in unit time in particular direction. So we can define the velocity as the speed of an object in a particular direction, or the displacement of an object in unit time, or the distance covered by the object in a particular direction. So we can express the velocity. As velocity is equal to displacement by time taken. We can denote the velocity by the symbol v, and the displacement by the symbol s, and the time by the symbol t. So we can express the velocity as v is equal to s by t. Here the velocity and the displacement are vector quantities. To show the direction of motion, we have to specify an arrow mark on v and s. So the arrow mark v and s shows the direction of motion of the object. So velocity is expressed as v is equal to s by t. And then the SI unit of velocity. SI unit of velocity is same as the SI unit of speed, that is meter per second. Next, types of velocity. Uniform velocity. If an object if an object covers equal distances, if an object covers equal distances in equal intervals of time, in equal intervals of time, in the same direction, then the velocity of the body is said to be uniform. If an object covers equal distances in equal intervals of time in the same direction, then the velocity of the body is said to be uniform. We can give the example of a train moving with a speed of 50 km per hour. If a train is moving with a speed of 50 km per hour, it covers 50 km in every 1 hour. It means it is covering equal distances in equal intervals of time. So the motion of the train is an example of uniform velocity. And next, non-uniform velocity. Non-uniform velocity. The velocity of a body can be changed. Velocity of a body can be changed in three ways. First one, by changing the direction of motion. By changing the direction of motion of the object. By changing the direction of motion of the object, the velocity can be changed. Or by changing the speed of the object. By changing the speed of the object, the velocity of the object can be changed. Or by changing both the speed and the direction of motion, the velocity of the body can be changed. So the velocity of the body can be changed by changing the direction of motion, or by changing the speed of the body, or by changing both the speed and the direction. Next, non-uniform velocity. So non-uniform velocity means non-uniform velocity. If an object covers unequal distances in equal intervals of time, in the same direction, or if an object covers equal distances in equal intervals of time, by changing the direction of motion, then the object is said to be moving with non-uniform velocity or variable velocity. So if an object covers unequal distances in equal intervals of time in the same direction, or if an object covers equal distances in equal intervals of time by changing the direction of motion, then the velocity of the object is said to be non-uniform or variable. So we can give that example of the freely falling body. When the body is falling freely, so its speed, the speed of the body increases as it approaches the ground due to the acceleration due to gravity. So as the speed of the body increases, it covers unequal distances. As the speed increases, it covers unequal distances in every successive in every successive second. So it is covering unequal distances in equal intervals of time. So the freely falling body is an example of non-uniform velocity. And one more example we can give, the car moving in a circular path. The car moving in a circular path. So the car is moving in a circular path with a constant speed. It is covering equal distances in equal intervals of time. But the direction of motion of the car is changing continuously along the circular path. So here it is covering equal distances in equal intervals of time, but the direction of motion of the car is changing continuously. So the velocity of the car is said to be variable. Next, average velocity. When an object is moving with a variable velocity, when the object is moving with variable velocity or non-uniform velocity, then the rate of motion, of an object is described in terms of its average velocity. When the object is moving with a variable or non-uniform velocity, then the rate of motion of an object is described in terms of its average velocity. Next, when the velocity of an object changes at uniform rate, when the velocity of an object changes at uniform rate, then the average velocity is defined as the arithmetic mean of the initial and final velocity. When the velocity of an object changes at uniform rate, then the average velocity of an object is defined as the arithmetic mean of the initial and the final velocity. The initial velocity is denoted by u and the final velocity by v. So the arithmetic mean of initial and final velocity is given by u plus v by 2. So the average velocity of an object when the velocity changes at uniform rate is v is equal to u plus v by 2. Next, when the velocity of the body, changes at non-uniform rate, then the average velocity is given by the ratio of the total displacement to the total time taken. So the total distance is given by S1 plus S2 plus S3 and the total time as T1 plus T2 plus T3. So when the velocity of an object changes at a uniform rate, then the average velocity is defined as the arithmetic mean of initial and the final velocity, and when the velocity of an object changes at non-uniform rate, then the average velocity is defined as the ratio of total displacement to the total time taken. When a body is moving with constant velocity, then the change in velocity is zero. It means, suppose if an object is moving with 40 km/h speed throughout its journey, then there is no change in velocity. So change in velocity is zero. Next, suppose if an object is moving with variable velocity, variable velocity, then the change in velocity is not zero, It means, suppose if an object is moving with 30 km per hour speed initially, and then its velocity increases to 50 km per hour, then the change in velocity is 50 minus 30, that is 20 km per hour. So it means if an object is moving with a constant velocity, then the change in velocity is 0. And if an object is moving with a variable velocity, then the change in velocity is not a 0. So the quantity which measures the rate of change of velocity with the time. Rate of change of velocity with the time is called acceleration. So the quantity which measures the rate of change of velocity with the time is called acceleration. So we can define the acceleration. As the rate of change of velocity with the time. And we can express the acceleration. As change in velocity by time taken. So the change in velocity is given by final velocity minus initial velocity by time taken. The acceleration is denoted by the symbol small letter a, final velocity by v, and initial velocity by u, and the time by t. So the acceleration can be expressed as a is equal to v minus u by t. And you know what the SI unit of that velocity is meter per second, and the SI unit of time is also second. Here we have 2 units of time. So the SI unit of acceleration is meter per second square. The value of the acceleration, it may be 0. The value of the acceleration, it may be a 0, or it may be positive, or it may be a negative. When velocity increases with the time, then the final velocity is greater than initial velocity. So the acceleration is positive, and this acceleration is called positive acceleration. And when the velocity of the body decreases with time, then the final velocity is less than initial velocity. So when the final velocity is less than the initial velocity, then the acceleration is negative. So this acceleration is called negative acceleration, and it is also called retardation. And when the velocity of the object is not changing, it means when the velocity is constant, or uniform, then the change in velocity is 0. When the change in velocity is 0, then the acceleration is also 0. So the value of the acceleration, it may be 0, positive or negative. When the velocity increases with the time, then the final velocity is greater than the initial velocity, then the acceleration is positive, and it is called positive acceleration. When the velocity decreases with the time, then the final velocity is less than the initial velocity and the acceleration is negative. The negative acceleration is also called retardation. When the velocity of an object is uniform, then the change in velocity is 0. So the acceleration is also 0. Uniform and non-uniform acceleration. If an object changes its velocity, at uniform rate, then the acceleration of an object is said to be uniform acceleration. If an object changes its velocity at uniform rate, then the acceleration of the object is said to be uniform acceleration. Example, when you roll a ball on a smooth inclined plane, the speed of the ball increases with the time uniformly. So the motion of the ball on the inclined plane is an example of uniform acceleration. Next, non-uniform acceleration. Non-uniform acceleration. If an object changes its velocity, at non-uniform rate, then the acceleration of the object is said to be non-uniform acceleration or variable acceleration. Non-uniform or variable acceleration. If an object changes its velocity at non-uniform rate, then the acceleration of an object is said to be non-uniform or variable. Example, when a train leaves the station, its velocity increases slowly, and after some time it attains maximum velocity. And as it approaches another station, its velocity decreases. And finally it comes to rest. It means the velocity becomes 0. So the motion of the train along its journey is an example of non-uniform acceleration. Now you know what is acceleration. Acceleration means the rate of change of velocity. With time is called acceleration. And the acceleration is denoted by A is equal to V minus U by T. And the acceleration, it may be a positive, it may be a negative, or it may be a 0. When the velocity of the object increases with the time, then the final velocity is greater than initial velocity, then the acceleration is positive. When the velocity decreases with the time, then the final velocity is less than the initial velocity, then the acceleration is a negative. The negative acceleration is also called retardation. When the velocity of an object is uniform, then the change in velocity is 0. So the acceleration is 0. Next, uniform acceleration. If an object changes its velocity at uniform rate, then the acceleration is said to be uniform acceleration. And if an object changes its velocity at non-uniform rate, then the acceleration is said to be non-uniform or variable acceleration.